Hello everyone, welcome back to my messy lab. Well, today I have this famous signal generator. It's a Fluke 6071A, and this unit is capable to produce a sine wave from 200 kilohertz up to 1 gigahertz and 40 megahertz, sorry. So this is well known to prone to fail because of tantalum capacitors, electrolytic capacitors. The unit is off since very long time, and I know that it's not operative, so I have two of these to repair with the same fault. So I will plug in and see what's happened, and then I will describe a little bit the unit. So let me plug it in and see how it's going on. The unit is plugged in, and there is a rear switch exactly here, which this one, which will get power to the internal power supply. And here we have the standby light. So as soon as will be powered on, should be go in standby, and the standby lead should light, and the switch is in standby position. So you should see the lead coming out. So let's see if it's glowing. Yes, it's glowing. So it seems that at least the main supply is healthy. So let's try to switch on. Nothing happened. So also the standby light is going dimmer. So I don't know, it's very dim. So let me open the unit and see how it's inside. All the screws have been removed, and yeah, this is how it looks. Well, this unit is quite complex. Actually, there are, let me put the cover apart. There are two main chassis like this, and each chassis has populated on both sides, and each of that contains several circuit boards, and this is the main power supply with regulators here, I think, if I'm not mistaken, if I may remember well. And over there are some capacitors, is the main board. And as you can see, there are two plugs, both of these, which are plugs that are coming out from the power supply. Well, to troubleshoot this unit, normally is removed one of those at a time in order to see where the load on the power supply is, if it is in the upper or in the lower deck, sometimes in both. The fan is used as a monitor. When the fan starts to run, it means that the power supply is operative. So removing those plugs over there should give us life on the power supply. So let me try to do one at a time and see if we can have some life signs. So turning around the instrument, I see that I just forgot to mention this plug. This plug is the digital power supply ribbon cable, so it's going to the front panel, and in the front panel leave also the microprocessor board, and so all the logics are inside here. All the ROMs which control not only the operative system of the instrument, but also the adjustment of several circuits inside. So there are ROM that are burned at Fluke company when it has been manufactured, and they are matching the circuit characteristic of each instrument. So it's quite complex if one of those will be faulty. However, so let's go ahead and try to remove one at a time and see if the fan will be start to operate. Otherwise, we will have a problem in the main power supply. So let's go ahead. As you can see, I have removed the first plug, and there is rated on out, and on the other there is rated synthetizer. So this is feeding the output section with the amplifier, the signal amplifier, and the other side is going to the synthetizer, and this one is going to the front panel. When it is removed, this one, the unit will go directly on the on position, so the standby is not anymore functioning. So let's see what we have now. So I switch on, and no signs. So let me remove the other one. Second plug is removed. Powering on. Nothing. I have to say that the standby lead is very dim. I believe that we have some problem in the main power supply. However, let's try to remove also the digital section connector and see what's happening. All right, so all the loads has been removed from the main power supply, and switching on, the fan should turn, but we don't have any signs like that. Of course, here we don't have any other sign because there are no connection. So for sure we have a problem here in the main power supply, so I have to take it apart and see what's happening inside. As you can see, I have opened the two decks of the instrument, and I have also removed the cover from the power supply. So next step is to grab the schematics and start to check those capacitors. And here there are two boards where, as you can see, they are populated with a lot of tantalum capacitors. So all of those should be checked and maybe replaced. The instrument is quite old, probably in the middle of 80s. Despite here is printed in 1979. I believe that this unit has been manufactured in the middle of 80s, maybe, I'm not sure, because actually I am not able to find any information about that, and I'm not able to understand from the this serial number which is the year of manufacturing. The unit is well, has these two options: the rear auxiliary output, which is this one, RF output, and the reverse protection reverse power protection, which is very helpful for the output stage of the RF amplifier, because if you put some DC voltage, it will shut off immediately the output. I found it helpful because during the use of this signal generator with old vacuum tube radios, well, if you don't use a DC blocking capacitor, you can damage any modern signal generator. So this unit, if you forget to install the blocking capacitor, will shut off the output and save the output amplifier. Here, as you can see, there is a big roll of coaxial wire. This is, of course, the delay line, as you can see also inside here. So, well, the instrument is clear. It's quite complicated. Let's go ahead with the power supply check. I grab this schematic and see where I start to check. Of this era, the manufacturer provide a very helpful and full of information service manual. This is just 2 of the 5 manuals that I have. This is for the schematic and service manual, as you can see, but I have also circuit description, user manual, programming, quick start. So there is a very lot of information about this instrument. So let's go ahead with the schematic. And this is the input section of power supply. So the line input is right here. And here is the primary section, which is composed by these 2 birds here and some other components back over there. And there is also this small filter bird. So let's see the starting point. So for sure we have a healthy input because we don't have any fuse that is blowing. This is the standby on remote control from the front panel, which with the removal of the front panel connector, it is continuously in the on position. I wish to find the fan, so let me study a little bit and then I'll be back because I want to see which power should be checked first. As you can see, this is one of the 2 birds, the small bird right here, and one is for plus 12, minus 12 and plus 24 volt. Is a series regulator, as is right here, but this should be checked later. And this is the plus 5. I believe this is for the digital supplying, and this is the other small bird. Here we have a filtering section, and well, actually I'm not sure if he is also doing some regulation. No. So okay, this is a small bird which is located right behind this cover that I will open later. But first of all, I want to check this bird, and with the ohmmeter I want to see how these capacitors are if there are some leaky or short capacitor. So let's go ahead. Well, while I was making some random test on the capacitors, I went on this capacitor, which is right this one. So this is the ground, and of course it's indicating 0.2 ohm. The other side is the same. So here we have a dead short, and well, since here is going out, we could have a short circuit here internally, or maybe outside. We don't know. Maybe it could be also this capacitor here. So this is to be traced back. So I need to see if I can remove this plug, which should be this one, I believe. Let's see, E8, no, E1, 2, 4. Let's see if I can find. No, so, okay, E1, 2, yes, okay, it's over there. So let me remove it and see which result we have. Yeah, you see, now is and it's charging. So for sure we have a problem on this board, since I have removed this connector. So I suspect that this capacitor is faulty, because 22 microfarad, it looks like, if I remember well, this is the typical capacitance of the tantalum capacitor which populate this instrument. So that could be the cause. So let me see, C18. Let's see if I can find it. What I've done, in order to be sure that the fault is in this section, I have removed J3, which is right here, and have reconnected J4, that is the one that is going to the other board. And checking here, we already have a short circuit. So if I remove this and check again, now we don't have a short circuit anymore. So the short circuit for sure is in this board right there. So I need to replace for sure this C18, that it is right here. Well, I say that for sure because the instrument became faulty after a long non-usage period, so I believe that is a capacitor problem. So let me remove it and make some checking more in depth. As you can see, I have replaced the cap. So let's try to power on and see what happened. Well, actually nothing. So probably we have some other short. Let's see. Yeah, no signs. Okay, so yeah, you see there is the neon lamp is sweeping more to see if I can find some other short circuit, and I found that here we have another one, 07 on both sides. So on this line we have another short, so I will remove those two birds and check both for additional short circuit. I have removed both regulator boards, and so let me try to switch on now. No signs. That is strange. Okay, so we probably have some other. Oh, yeah, fan is starting now. So probably there is something that is still loading the power supply. So let me switch off. I have switched it off, and the capacitors charge maintain the power supply still on for several seconds. So I need to fix these two boards, because I believe that the unit without load is not it's not healthy to use this power supply without load. So let me try to see if I can find something that is shorted out for sure on this circuit. So let's go ahead. This is the +5 regulator board, and the other one I have checked all the capacitor and they looks nice. I mean, not any short, but here I have already checked all the capacitor, but the last one, let me see if I can do it one hand. Not easy. Look at that, another short circuit. So let me replace it. I have a ton of tantalum capacitor. This is something that I always keep available to repair this type of instrument. And this is the replacement. It's 10 microfarads. Come on. It's a 35 volt. The original one was rated at 20 volt, 10 microfarad. So let me replace it and test again. So the capacitor, you see the yellow one, is replaced. The board has been reinstalled, and let's see what's happened now. All right, yes, fan spinning it should. So it seems that power supply is back to life. Let's take a measure of some output over here. So this is +24, nothing. -13, -25. So here we have something wrong. +5 is okay. +13 is okay. So we still have something wrong here. So let's go ahead. So after a more deep check, I see that nothing seems to be wrong in the power supply. So I decided to connect only the front panel and see what is going on. So let's see what we have. Oh, okay. Yep. So it's back to life. Very nice. So okay, now of course we will get me a lot of error, because both of the upper and lower deck are not connected. So what I will do, I will plug the relevant connector one at a time and see if the instrument still will remain on. So let's go. Now I've connected the output deck. Let's see the behavior. Yeah, the fan is trying to run, but seems that can you? I don't know if you can hear the fan is changing the speed since we have a load here. So for sure in the output deck there is something wrong. Let me try the synthetizer deck. So now I've connected just the synthetizer deck. No. Yeah, it's load. There is an overload also in this deck. So it's clear that we have an overload on both deck. So let's go ahead with the troubleshoot of one deck at a time. So let's go ahead. So this is the synthetizer deck, and this is the power supply connector that is giving all the power required for this section. So what I will do, I will remove both covers, the lower one, and let me tilt, and the upper one, since the way that it is designed, this instrument, is that from one bird will pass all the power required to the next one through pins. So what I want to do is to trace the last bird and start from the last one and remove it one at a time to see if I can find the short circuit on this deck. So let's go ahead to see if we can do it easily. And this is how the synthetizer deck looks like. Well, it's a very impressive unit. Is full of components, and it's a very well made. And this is the input, the power input, which is right here on the opposite side. And this is the way that the instrument get the power to the other birds through these pins and as a socket. So what I will do, I will trace to the last bird. I will start to remove one from another one and see if I will find the place where there is the overload. I have already seen that we have a short circuit here. If I'm going to check C3, we have 0.2, so we have a short here, but we need to find in which of those birds is the short. So let me go ahead and I'll back when I will find the place. Well, trying to understand the power routing on this deck, what I have found is that the input is right here, and we have 1, 2, 3 lines. One is coming right here. The other two are coming on this interface board, which in turn get the power to all the other birds. So what I want to do right now is to remove this one first and see if our short circuit will disappear, and then if it will not, we will have just two birds that are suspected to be faulty. So one will be this one, and the other one the input one, so the first one. This ribbon cable is the data input and output, so it's the digital control of the all the instrument. This is coming from the front panel right here, and it's going to the synthesizer deck, and on the other side here, as you can see, on the output deck. So this is something that I'm not checking right now because should not be a load for the power supply. So let's go ahead. What I have done is to remove this bird first, but nothing has changed, so the short circuit was still present, and by removing the other two birds over there, it disappeared when I remove the interface board. I have checked all the capacitor on this bird, and they are fine. So since this interface board is splitting in 3 ways, I've traced that the short circuit is on the 4th pin here, but is in the 2nd here, 2nd there, and the 2nd here. So what I want to do is to use the ohmmeter and go to each of these pin here. So the 2nd here, 2nd here, the 2nd there, and the 2nd over here, to see where the line is shorted. So let me grab the ohmmeter and go on the 2nd here. So 2nd, and here we have a short circuit. 2nd here, no, 500 ohm. 2nd there, no short circuit, completely open. So this is the line that is shorted. There is something that is shorted. So let's see where it go. Okay, so it go on this board right here. So let me remove it and see if I can find the faulty component. As we can see, from this board is going also on the other side on this board. So I will remove this one first. So this is the last board. Actually could also be this one. So let me remove this plug and see if I will have some result. Okay, so let's go and check the full line. Okay, so let's see now. Here, yeah, we still have the short circuit. So let me remove the bird and see what's happening. The bird is removed, so let's see which result we have now. Yeah, short circuit disappear, so it means that we have a short on this bird. So we need to find which component is. So let me do a check and see if I can find it. Well, I found that one of this capacitor here was short. So I replaced both because I see that somebody has been in before me and replaced already this one. So I'm not going to completely recap because of course it will take an advantage, but it's really time consuming. There are hundreds of capacitors in this instrument, so I don't want to make a full recapping. So I'm just going to recap the faulty, and when I see that there is a place that already has been faulty, I will make some change more. So it seems okay now. Let me put back and see the result. The board is reinstalled. Before I complete refit all the screws, I want to check if there are some other shorts, because it could be also a multiple fault. So I want to check right now the result on this. So here we have sorry for the glare, 4 kilo ohm is okay. Next one is 1 kilo ohm is okay. Next one is the one that was shorted out, is 199 ohm. It's almost okay. And the next one is the last one, that is 208 ohm. So no shorts are present now. So what I need to do is to install this board and the other on the opposite side to see if we'll still have a right resistance measurement, and then we can plug in the synthetizer section and see if go back to life. Let's go ahead. So all the burrs, screws and nuts are back in place. The wire is connected, so the output is still removed. I have just plugged in. So let's see what we have now. If yeah, okay, so now seems that it's not overloading anymore. Of course, we are seeing a lot of errors here because we still need to connect everything. So, but the digital sections, it's working, and also the synthesizer is not loading anymore. So now we need to go on the other deck and see if we can fix also the overloading in the output deck. I mean, it's called output, but there are many other circuits. There are the modulations, the AM and FM modulation boards, and other stuff. So, however, let's go ahead and see if I can fix also the other section. After the removal of a ton of screws, I have opened it. Not all, I still need to open one side of those decks. Well, this is the output section, and here we have a multiplier by 2, and looks very complex with a lot of those hybrid circuits with the ceramic support. Well, I will use the same strategy of the other side. So the power is coming in from this point. If I have seen, yeah, you see, it's over there. So just below the digital commands. And what I want to do is to see the routing of the power supply. Here we have a plug that is very helpful because by the removal of it, we'll exclude the lower section of this output deck. So let me go ahead and see if I can trace where we have an overload. Of course, I need to check here. For sure, I will find a short circuit. So let's go ahead. And as expected, we have a short circuit here. Look at that, 0.2 ohm. So let's go ahead with the trace back of this short circuit. The removal of this plug does not help because I still have the short circuit. So since it's going on the other side from this point and the other 2 points right here, so it's clear that I need to open also this side. So let's go ahead. Now all the covers of the decks are removed. This is the modulations circuit boards. So look how beautiful is this instrument. Well, what I'm going to do is to remove one at a time these birds in turn until I will find, oh look at that, here already has been in. So maybe I will start from this, but also over there, look at that. Yeah, that this is something that we know these instruments are prone to fail because of this tantalum capacitor. But at least I have to say that they fail, okay, but they don't leak. Not like electrolytic capacitors, the standard electrolytic capacitor, which are leaking and damaging the circuit board. So in this case, they can short out, but just replacing it, you will have the instrument back to life. So let's see if we will be lucky like so. Let's go ahead and see. Last bird removed is the one that live here, and it is this one. So removing this bird and checking the resistance here, we don't have anymore the short circuit. I've noted that there are other pins here. I mean, there is a socket that can be removed easily to check also if some shorts are here. I have done it, but nothing has changed. So it seems that in this board everything's fine. Well, so now I need to check the bird and see what is wrong. Look how many socket wrench I've used, trying to find the right one for the removal of those nuts. 1/4. Well, let's go ahead. Making a quick test. It seems that we have 3 capacitors that are in the same line. So instead of see which is the one that is shorted, I will replace all 3. So I think it's better to have this this way to replace the capacitor. So at least we will have more capacitor brand new. Let's go ahead. So all the boards are back in place. I have replaced the 2 capacitor, 1 and 2, which was involved in the shorts that I found. Actually, they are on the same line. There are other 2 in the same line, but after 100 ohm resistor, so, or 200, I can't remember. So, well, they are fine now. Before I fix with all the screws and all the nuts in the SMA connector, I want to check if there are some other short for, in the case, I mean, there are some multiple errors or multiple short circuit. I have reinstalled all the plugs. So going to check, this is the first, it's 500 ohm, this is 700 or something like that. This is the ground, and in fact is short out. This is 240, and this is 120, 30 roundabout. So, well, I think we don't have any short anymore. I mean, no longer. And look at that. Also here, somebody has been in before. So, what I'm going to do is to fix everything with, to install all the screws and nuts and put all the wire and see if the instrument will not shut down because of an overload. So let's go ahead. So everything is back in place here. All the screws and nuts are tightened. I have reinstalled the plug for the output deck power. So it's time to make the test of all together. Let me turn around the instrument and see the behavior. Well, the instrument is plugged in. Let's see. Okay, so it seems that we still have an overload. It's not able to start up. So let me switch off and remove the plug and check again. So the plug is removed. Yeah. So in the output deck we still have some overload. So we need to check further in these birds. So let's go to see if I can find it. So very strange. I have a short circuit in the same line. So let's see if I made some mistake, maybe with a reverse capacitor. No, this is okay. And this is okay. That's very weird. Why I have another time the same short circuit? Okay, so let's remove again the birds and see why we have another short circuit here. This time I choose a different strategy to find the short circuit, since this board made also the interface of all the other birds, and what I found is the short circuit is up here. So it's clear that we have a short circuit on this small bird. So let me remove it and see if I can find it. Back in place. As you can see, I have installed an electrolytic capacitor instead of this tantalum capacitor, because what actually happened is that I don't have a capacitor rated at 35 volt. I can arrive only to 16. So for test purpose I will use that electrolytic capacitor to see if the instrument can switch on with all connected. So what I've done, I've already checked it here. So my short is gone. So let's see if we have some other shorts. Well, what happened is when I will start the instrument, it can happen that other capacitors will short out. So I will replace all of them in case. So let's try to start again. All the wiring is back in place, except of course the those RF plugs. So let's see if the instrument will power on. Let's see what's happened now. Okay, no, yes, okay, so now it seems that it's powering on. Let's see if we remain on and what is doing. So it's self-check now. Of course, there are a bunch of error codes. These are error codes. To eliminate the error codes, you press the output power or any other button, I believe. This interrogate give the errors. So these are error codes. Well, of course, we have all the RF signals not connected. But yes, the instrument seems to be back operative, at least is powering on. Now we can also expect that there are some other faulties, since there are a lot of capacitor in this instrument. So let me connect all the RF plugs, and then we'll check if we have an output from this signal generator. Well, while I was attempting to make some additional tests, I finally have magic smoke. Unfortunately, I didn't record it on the camera. So this capacitor, as you can see, there is a metal ball outside. Well, this capacitor was exploding. I just was able to stop just before it happened. So it seems that I have to remove also this board and replace this capacitor. So let's go ahead. I have replaced the broken capacitor and also the other one that was close to it. As you can see, it has been replaced already, some cap here. And to be honest, it doesn't look healthy. Here there are some weird sign. Also on this one. Let's see if I can make position. There is a weird sign on the side. There's a white line, and there is another one with the top with some discoloration. Also this one, you see this black mark. It looks like overheating or something like that. So probably I will go to replace all the cap, or at least those that doesn't look healthy. So let me replace those, and then we will try to restart the unit. So what I've done is to replace several capacitor on the board. I found one of that open. Then I have rewired, all the connection required to let the instrument run. This is going to the rear panel as this one, and there are other two. So I want to test the unit right now. So let's see the behavior. So the instrument is powering on, and okay, it's giving me one error. Let's see. So now it's not giving me, it seems that there is an error, if I remember, should be in the maybe in the main loop, but I'm not sure, so I will check later. However, I have made the setup like that. So this is the output, and the marker is exactly at 299.93, so it's not so far. Minus 12.9, and here is minus 10, so probably it's not completely aligned. But let's see the behavior when I turn the, oh, look at that. Yeah, main loop is going out of lock, so this is the issue. Yeah, now it's locking, now it's out of lock, so it seems that it needs some adjustment, since the main loop oscillator is designed with the varicap diode, and maybe that the voltage is not well adjusted. So I'm going to make this adjustment and see if this can fix the problem. So let me go ahead. Well, what I've done, I performed the complete synthetizer alignment, and it was slightly out of alignment, but I found that the problem that gave me the error of out of lock and went out of lock, it's because this SMA cable was not well connected. I mean, the internal pin was not, it was going a little bit deeper in the plug, and was not connecting the wire as it should on the plug over there. So, however, this is what the instrument is doing. So it's going directly to the main screen, right, with all the leads without any error code. And this is the Spectral Analyzer. What I'm going to do is to move 10 megahertz with the knob, and as you can see, it's pretty stable, and it's already reached the top limit to 1 gigahertz and 50 megahertz, which is exactly this point. So, I mean, let me get a better view. 1.05 gigahertz. Yeah. So we have 1.4995 gigahertz at minus 14 dB. Well, actually I'm at minus 10, but I have a very long cable with a lot of I mean, adapters, so of course I have a huge loss, but I mean, I'm pretty happy. I have reached the point where I want, so to have the instrument working and solid, stable working. So this is a 10 megahertz signal. So what I will do, I will completely reassemble the unit and will make some more tests. This is the final result. So the instrument is completely reassembled. I have also 4 rubber feet in order to have the instrument lifted a little bit from the table. Actually the instrument is very heavy and the original plastic feet are always damaged, so I will have to manage a different solution. And to achieve this result, I have the help of these 4 manuals, and for future I will also maybe use this, since I have an HP 85 calculator under restoring, and yeah, maybe in the future I will try to control the instrument through the HPAB port. And this is the amount of capacitors that I have replaced. Some of them are, failing and leaking or open, but the majority are still okay. I just have replaced it for safety. Of course, the instrument will have to take an advantage to a complete recapping, but since I'm surrounded of future projects, so for the moment will be okay like that. So it's fully functional, and so this is the exterior after light cleaning, and this is the sine wave that is coming out from the instrument. So it's okay, and this is my setup. I have connected to this very nice modulation analyzer, which I have repaired several years ago, and unfortunately I didn't capture the video. So this is the frequency that is running. There is a little bit of different, but well, the internal 10 megahertz reference, maybe they are not matching, but however, that is not our purpose. So if I'm going to put a 30% modulation, if I go to here and check the AM modulation, we are at 30.85, so it's almost there. And I can check the audio frequency by this, and in fact it's 1 kilohertz. So same thing I want to do with FM, and we are at 5 kilohertz of deviation. And if we go to FM, yeah, we have 5.1 kilohertz deviation, so it's quite nice. And well, we can also maybe measure, yeah, we have still 1 kilohertz, and we can also measure the distortion, which is 0.75. so it's not an audio amplifier, so the quality is not perfect, but since this signal generator will be used just for troubleshooting other equipment, I can say that I am pretty satisfied. So I can change the frequency, going maybe down to or maybe up. Let's say I can go to 1 gigahertz. So this is our sine wave, so still okay. And if we go to the Okay, we can see that the distortion has been reached 3%, but it's reading 1 gigahertz. So, and the FM still is 5. So let me move this to maybe modulation to 55 kilohertz, and over there we have 54.1. So it's not too bad, and well, we can say that the instrument is running as it should. Yeah, over there we can see the FM modulation. So it's out and in. This is the AM. Well, actually in FM we cannot see difference. The glitcherings that we are seeing is because we are running almost to the limit, since this 1 gigahertz oscilloscope is very close to the limit, and also this connection, well, it's not so the right level. I mean, it should be different. Well, but for the moment, I would say that I'm pretty satisfied for the result. So this is something that take a very long time to do, and not all the things I have done are captured in the video, that it's already quite long. So I hope you find of your interest this video, and well, we will see in the future more project of instrument and radio. So see you soon. Bye.